So on more on iterations in the exercises, number 6, there's a question where you're moving a turtle around and you need to check if you need to bounce off of the second turtle. And so what we're going to do here is you need to check if the x-coordinate of the first turtle is within a range around the x-coordinate of the second turtle. And luckily we can get the x-coordinate of each turtle because we can do t1.xcore and then we can do t2.xcore. So how do we tell if t1 is within a range of numbers? Well, if you remember back in elementary school, we did a number line, and then we had like two bubbles and then an arrow going like to the right, and then on the right side there was a bubble around the number, and we had an arrow going left. And those arrows and bubbles, they represented inequalities, right? So that's how we represent a range of numbers. So we're going to do x is greater than some number like -2, and x is less than some number like 3, right? Well, if both of those inequalities are true, then what range of numbers does that represent? Well, it's -1, comma 0, comma 1, comma 2, right? So then, so these are, if both of these statements are true, then these are the numbers that that are represented by these two inequalities. So that's the same kind of tactic that we need to use up here, right? So we're going to say if, well, first you want to move the turtle, so move t1, right? And then we're going to say if, and we're going to do t1.xcore is greater than, and we want to compare t1's xcore to t2's xcore, right? But minus a certain amount by a buffer. So I'm going to use 10 pixels. So we'll do t2.xcore minus 10, right? And t1.xcore is less than, and now on this time I want to check if the t1 is less than this amount here, right? So it's t2.xcore plus 10. So let me go ahead and do that, and we'll say x2.xcore plus 10, right? Okay, cool. So if both of these inequalities are true, then that means the turtle is within 10 pixels on the left of t2, and it's within 10 pixels on the right of t2. So then next we need to check the y-coordinate, right? So you can say check y-core, and that's going to be done the exact same way, right? Except it's not going to be x-core, it's going to be y-core, right? So you want to check if it's greater than t2.y-core minus 10, and if this t1 y-core is less than t2 y-core plus 10, right? So if that's true, both of those conditions are true, or all four of those conditions are true, then you know that t1 is within a 10 pixel hitbox around t2. And if that happens, then what do we want to do? We want to bounce, right? So just kind of like turn around, and that's it, right? Next thing we want to do is we're going to move t2, and then you're going to check t2, check hitbox for t2, right? See if it is within 10 pixels of t1. And that's the way that that assignment gets done. And the reason why I'm kind of going over it right now is because in Pong we're going to revisit this algorithm, and we're going to use it to determine whether the ball should bounce off of the paddle, right? We're going to create a little hitbox on the front of the paddle, and if the ball enters that hitbox, it bounces off the paddle. So this is a great place to front load that, and maybe it won't be so shocking when we talk about it in the Pi game portion of the curriculum.